Hi, today I want to show you the assembly of an AeroBow serving jig. At the same time, discuss about the components, the material, and the approach towards why these things work the way it should. Okay, first of all, you start with it. The main cause of this aero serving jig is in this piece, which is the drag system. The drag system involved with 5 carbon drag washer, 4 titanium washer, and also a spring washer. And to make the spool catch, which is this piece, it's made of stainless steel, it's 303, and the main shaft, the 3 rollers, and the screws are more made of GR5 titanium. To make this operating extremely smooth, you can see there's actually 10 bearing system in it. First of all, there's 6 flange ball bearing, there's 2 ball bearing that's pressed onto the main shaft, and there's 2 truss bearing which contained the dog and the spool catch. All right, first of all, let's assemble the pieces as we go forward. I'll show you piece by piece. First of all, to put it together, we start with a bearing bond to make sure that all the pieces are stay together correctly with the minimum tolerance that's possible. So I put 6 flange bearing in on both sides. And of course, clean it up nicely. Okay, after the flange bearing go in, we make sure that the shafts are all done right. Then we put the 2 pieces together. You can see it's really tight tolerance. And some people say we can skip the bearing bond, but just in case there's more than half thousandths, the bearing bond should pick it up very nicely. Now you can see that the body is actually indexed. In other words, let me pick that apart so you can see. It's actually cupped. See that how these 2 indexed together? So when you put the 2 together, they're actually indexed and or what you call mated. You see right here, you can see much clearer now. I put it together, and then I'll put the 2 titanium GR5 screw that we custom make for this purpose. It's actually not just a screw. It actually behave more like a pin first, and then we screw it. So the tolerance of this piece on the strictness is as close to 0 as possible, being a 2-part piece. Of course, 1 part will be the highest tolerance. Now we use a Q-tip to clean up all the inside area, just in case there's any bearing bond that bleed out. Okay, now this piece is considered done. All right, now we're doing the main piece. We'll start with the main shaft. The main shaft have 2 sides. This is called the knob side, and this is called the drag side. To start with the drag, we deal with the truss bearings. So let's go in and put the truss bearing together. We pick up the first we put in the copper spacer, so that the ball bearing and the bottom of the truss bearing flange will not have issue. See, there's a rail in there. Okay, now we push this in, as you can see, it's very tight fit. There's no room in it for any error. Okay, that goes in. Then we put the truss bearing itself. You can see that's actually ball bearing here. And then put the top cup. After we finish that, you can see it's barely go in, and this is called the spool catch. The spool catches go on top of this. Then we'll put the basic spool catch rail, the ball bearing itself, and then the top cup. After that, we put in now, this is all the important spots comes to show in. This is actually called the drag cup. This is how the drag actually be contained. Now after we put a drag cup in it, this is where we start using the PTFE grease. You want to put a little bit grease on the bottom and on the side. Now we start with first the graphite washer. After the graphite washer, we put a bit more PTFE grease in it. Then we put in the index square spacer. And after the square spacer, again, more PTFE grease, the carbon spacer, and then the index, and then we use the dimple spacer. After the dimple spacer, again, more grease. The carbon spacer again. Now go back to the original, the square spacer. It is very important that you do not change the sequence. If you do, the system will not function correctly and the drag will actually not work. So it has to be alternated, and the last piece on top has to be the dimple spacer. Because if you don't put the dimple spacer on the very top and put a square spacer on the top, when you tighten it, it will not function correctly. Now we're going to put the E-clip in it. The E-clip actually stays in right on the neck. Okay, after the E-clip, more PTFE grease, another carbon spacer, and then this is actually a pressure spacer that is dome in shape that provides the pressure for the entire operation. Then, to mix the life correctly, a tiny bit of oil on the bearing, and then we put the cup on top. Now, then the drag section is considered done. Now we're going to do the spool lock section, which will start with a Teflon washer. Then the spool lock, see, it is slotted so that it will go into the thing and the shaft, and see, it will not turn anymore. Then we use a drag cup, which involves a pressure washer, an O-ring, and just like before, a tiny drop of oil right here. And now these two pieces come together. Now you can see that this thing is indexed, just like this piece. See, there's a dimple right here. So to make the thing work, first of all, you have to align the top side, and then you align the bottom side, and the whole thing will push together as one, like that. Now whenever you push in it, you notice you can lock this part. It will push the whole thing down, and when you lock it, you can feel it locked. Now this whole thing is solid. Now in order to change your spool, very simple. Just turn this knob, 1, 2 turn. Push up, the whole thing will come out. See that, how this can do quick change spool? I will do it again, 1, 2. See, it's lock solid. Just turn it once, then a second turn, push it up, sideways. Alright, that concludes the assembly of the Aero Serving Jig.